Okay, what we're looking at here is a section taken out of a seminiferous tubule. And if you're having trouble envisioning what a seminiferous tubule is, my suggestion is that you go to Google Images, type in seminiferous tubules, and then you'll get a better understanding. Okay, so this represents kind of like the cross section. If I was going to take the cross section of the seminiferous tubule, and I'm taking a section out of it. Now it turns out that spermatogenesis is the term that we use for the production of sperm cells. So spermatogenesis. And Genesis means beginnings, and spermatogenesis therefore is the process of sperm production. Okay? And as it turns out, the process starts in the outside edge and moves stepwise through different stages all the way down to, you see at the bottom, way down here, these are the spermatozoa. Now they're not good to go yet. They have developed as much as they can within the seminiferous tubules, but they still are going to have a period of time where other metabolic pieces have to be put in place. Okay? So out here, this cell that is A is called the spermatogonia. So it's the start material, if you would. And what happens is that it is going to go through a process here of mitosis. Remember we talked about mitosis in Bio 11? It's basically you're taking one cell and you're duplicating it into two identical cells. Okay, that's all that's happening here. So this guy here, the product is called I'm going to move this over slightly, a primary spermatocyte. And this is arrived at through mitosis. So duplication event. So what was one spermatogonium is now two primary spermatocytes. From here, this is going to go down to D, and this is called a secondary spermatocyte. And this is arrived at through reduction division or meiosis. Remember we said in Bio 11 that meiosis is we take 2N, one 2N cell, and you make 4 N cells out of it. Yeah. Great. There. Okay. Okay, so I'm just going to erase this because it's starting to get in the way. Okay. Okay. This goes under a couple of developmental stages. First one, we call this an early, so E, D is this, B is this, and A is this, and so we're down to E, and this is called an early spermatid. And then you can see in this, it's maybe hard to see, but there's a little wavy wall here. And so right now, you can see that these little guys are kind of like embedded in the tissue just before they're going to be released. Okay? And so these guys here are late spermatids. And you can see that they've developed the tail. But if you look really carefully, well, I don't know if you can look carefully, let me zoom in a little bit more. If you look really carefully, the head of the what do you call it? The spermatid is malformed at this point. It needs to lose some cytoplasm and stuff like that. Remember we said yesterday that the sperm cell is really like a stripped down dragster. So it has to get more streamlined is the point here. And so once it gets into that point here, these are considered, at this point, they are considered the sperm cell. Okay? So it's a downward, the progression is from the outside of the seminiferous tubules into the middle. So if you were to imagine that this piece here is that this is like a piece of a pie that is replicated all the way around, boom, 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 like that. Then you see in the middle that there's the opening. And so that is the tube. Are you watching this? That is the tube that all of these feed into, like all these guys are going to feed into, which will end up out here, in this part here, called the epididymis. You can see that in the last one. Now they are actually stored here because they're still going through more maturation. You're thinking, geez, how long does this take? 90 days. 90 days start to finish. Now this may blow your mind. You think, okay, well, geez, it takes 90 days to make, 4 sperm cells. This can't be very efficient. Do you know how many sperm cells are made in a single day? 2 million. From the time that a boy hits puberty, he'll be producing an average of 2 million sperm cells a day for the rest of his life. Okay? So it is actually extremely, 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 extremely efficient. Okay? Now, there are some other players in this game, not just the spermatocyte, the spermatogonia to spermatocytes to spermatids to sperm cells. There are a few other players in the game, and I'm going to color them in. Yes. From the original spermatogonium. Oh no, that's a lie. 240 it should be 8. Well, when you start with the spermatogonium here, a single cell, it's going to divide by mitosis to produce 2. So you've got 2 identical cells, which are the primary spermatocytes. They're going to go through meiosis. So in meiosis, there's a double division in which each one of those produces 4. Okay? So that's 2 times 4 is 8. So they've got 4 out here. Really it should be 8. But I think that just for the sake of diagramming this, they'd be in the way. It'd be very confusing. Oh no. No, this is a cross section. Remember we said that this is like a bucket full of spaghetti. So if you took let's pretend that this is a seminiferous tubule, okay? Okay? Thank you, dear. Let's suppose that this is a seminiferous tubule. So at I was a cat. Okay, so at every point, as it were, in this very long tube, and this is very tiny in length compared to a seminiferous tube if it was to scale, that at every point I would be having multiple of these things around. So that inside here there's a thread that runs through these beads. That would be the interior of the seminiferous tubule. Okay? So from the outside going in, you're getting all of these events happening all the way along. So even though we're talking about you're starting with spermatogonia, at any given moment, you've got literally thousands of spermatogonia going through the first stages. And at the same time that they're going through stages, there are other cells in process already. So this is sort of like, what do they call this thing? An assembly line. It's sort of like an assembly line, where as soon as these guys go through mitosis to form spermatocytes, oh no, wait a minute. No, it would be 4, because one of the spermatogonia remains. To
how does that, you said that they make up to 1,000, not 2 million in a day?
Yeah.
Then this one you say there's 4 in a day?
From that single spermatogonia.
Oh, you have a lot.
Yeah, we got thousands going on. They're doing everybody's doing the same thing. So, like, if I was to say, okay, stop the clock, stop the clock. Right now, if I was to look at these very different places, there's going to be spermatogonia in the process of splitting. There's going to be spermatocytes sitting around. There's going to be some spermatocytes that are going to be going through meiosis now to produce secondary spermatocytes. So if I was to take a cross-section and look at it, you would actually see in time all these different events, all these guys in play right now. And that's why as soon as these guys drop off the bottom, these guys are developing into what they were. And it's sort of like a bucket brigade, more and more and more and more. And that's why you can get like 2 million in a day. Dude, that's a lot. But keeping in mind that, size-wise, these sperm cells are like tiny. Oh yeah. When, like, every one of these guys is probably not going to be viable in the end. If you look at photomicrographs of sperm cells, what you'll find is sometimes you have a sperm cell that's got 2 heads. Sometimes they have 2 flagella, which is a problem because then one flagella can be working against the other flagella and they go nowhere. Some of these guys are like stupid as a stick, and they're just gonna swim around and bounce into walls until they die. So the reason why you need a whole pile of sperm cells is that to make it possible for a successful pregnancy to occur, a successful union of sperm and egg, right? And even like, let's say in a single ejaculation you may have 2, I don't know how many million, let's just say for the sake of numbers 2 million. Most of the guys are just going to run out of gas and die by the side of the road. Very few of them are actually going to get through the cervix into the uterus and fallopian tubes. And even those guys that get through there's no guarantee that they're going to go anywhere. So it's like the winning sperm cell. Good job. It's like, wow, you really rocked that, man. Wow. Okay. So we okay with this? You're okay with the idea of this process. So spermatogonia, primary spermatocyte, secondary spermatocyte, early chromatid, late chromatid, sperm cell. Like that. Okay? So, two other players in the game. That's these guys that are way off to the side here. Well, one of them is off to the side here. This guy here, I'm going to color him pink for no reason. No reason. And they actually forgot to include another one, which I'm going to put in arbitrarily right here. Yeah, and what I'm going to do is how to make this one blue. And so these guys here represent the different stages of the products. But in order to make these products, you have to have accessory cells that are going to provide them with the nutrients, with everything that they need to actually go through the developmental stage. And one's called a Leydig cell, and the other one is called a Sertoli cell. And together they are what's the word? Collectively termed interstitials. Interstitials.